everyone. So today I'll be showcasing you a recent project that I have completed. The objective of the project is to automate infrastructure using Terraform and then creating an application to manage the gated infrastructure. So as you see on my screen right now, there's a three-tier architecture setup present. So our objective will be to use Terraform to create a similar architecture. So firstly, let me explain the three-tier architecture setup. So the tiers include web tier, server tier, and database tier. So what will be the web tier? So web tier will contain EC2 instances in public subnets across two availability zones. Now this will ensure that the code is application is available to the users at all times. And since they are bound in an auto-scaling group, whenever such any instance goes unhealthy, there will be another instance will be quickly set up. And we also have a bastion host which will act as a bridge to connect to the front-end instances, and they'll also be connected with a load balancer which will help to distribute the traffic and perform health checks. Now for the other two tiers, server and database, they'll reside in a private subnet, and they'll also be having a load balancer and auto scaling group. To ensure security, I have created a NAT gateway which will allow the EC2 instances in the private subnet to connect to internet, but only the allowed IP addresses will be able to connect to the servers. And for the database tier, I have included RDS, MySQL RDS, but there are several other options available. So I'll be showing you a demo first, then we'll go about the Terraform code, then I'll show you the Jenkins pipeline, and then after that, I'll give you a brief about the code, React and backend code. So let's begin. This is the interface that is made using React, and it is kept simple and minimalistic so that the user can easily navigate. So first, we will have to log in. So I for login and authentication, I have used Clerk, and you'll also need ngrok. So to directly put the details of the users in a database, you need an endpoint. And since the application is not deployed anywhere, so we can use ngrok to create an endpoint URL and give that to Clerk, and automatically it will send the details to the database, for which I'll show you the API later on. So I've given the option to log in using GitHub and Google, and you can also do the same using your email address. So I'll just quickly log in. So now I'll go to the dashboard, and now the first thing you'll see is the settings. So to configure the infrastructure, you will need to add the AWS access key and secret key. So I've already set up my credentials, and please make sure that you have the following permissions, because creating three-tier architectures requires access to EC2, RDS, VPC, elastic load balancing, and S3. So I have given the existing configuration page also. When the configuration is active, you will get to see the credentials or the endpoints here. And talking about the create configuration page, when I click this button, a Jenkins job will be triggered, and it will process uh, the credentials, and then create an S3 bucket, then Terraform plan, Terraform apply, and finally Terraform output. And then I've added some success conditions through which an API will be called and the details will be sent to the database. So let me click on initialize architecture. So I'll now navigate to the Jenkins dashboard. Now as you can see, there's a new job triggered. So I'll show you, yeah, the job is not triggered. So firstly it will, I'll talk about the Jenkins pipeline as well later on. So I'll just cut the video here and show you when the credentials are made. Jenkins job has been completed. So I'll walk you through these stages. First is the checkout from, so the Jenkins pipeline will clone this repository, then check for AWS credentials. So it will check if the entered credentials, these credentials are valid AWS credentials or not. After that, it will create a S3 bucket. So I have configured Terraform to use a remote backend, and all the state files will be stored in the S3 bucket. So for example, if the operation is destroyed, then the code will access the state file from the S3 bucket and destroy the configuration. Or suppose if the action is apply, then the new S3 bucket will be created and the state file will be stored there. Then I've used Terraform init, and it will initialize AWS and region. And after that, Terraform plan, then Terraform action, and it will then capture the Terraform output and send an email. And then after that will be called, an API will be called through which the details will be entered in the database. So first I'll show you the email. So this is the email that I received. this 2 minutes ago. As you can see, if you see the output.json, we have all the backend endpoint, we have the project DB, we have the application load balancer, and the project key from which through which we can use to connect to the bastion host. And now I'll show you the database. So this was the local MongoDB compass. So the entries are filled here. If I show you on the UI side, yeah, so you can see the application, all the details are present on the interface. And if you go to create configuration, then since I have only set up that only one active configuration can be present at a time, so you'll not be allowed to create another infrastructure. So now I'll show you how to use the infrastructure that you have created. Now I've navigated to the AWS console, and as you can see now there are instances running, and as you see these are part of the 3-tier infrastructure. And if I show you the RDS instance as well, if I go to RDS, so the RDS is also running instance project DB. So now I'll tell you how to you can actually access this infrastructure. Before that, I will also show you the demo. This is the application load balancer for the front end instance. So I have mentioned a script file from where you can upload your code here, and you can display anything you want. So for now, I have displayed here hello. Now let's now I'll show you how you can actually connect to the bastion host. So bastion host usually you have to provide an access IP so that nobody else can access your bastion host. So for now I have given it 0.0.0. So this means that anyone can access it right now. So navigate to your AWS console and you find the bastion IP. So this is the bastion public IP. Also, if you want to get the link to SSH, so you can get the command here. But before that, we'll have to download the project key, like the security key. So I have given the endpoint here, and if I enter it, it will prompt me to download it. So I've already downloaded it, and now you have to navigate to this folder where you have saved the project key. So this is the folder, and I'll run you through the steps of command that you need to run this. So let's go. You'll have to first uh, set the permissions for the project key so that it is not writable anymore. So sorry, I'll do this now. Since the bastionhouse is used to connect to the instances which are present in the private subnet, you will have to send this private key to the bastion host. So now you can use the scp command. I've already written the sample code here, so I've already sent it, but I'll also send again. So this is the code, and now to connect to the bastion host you will require this ssh command. Let's connect to ssh. So now we are in the bastion host. To access the private to access the instances which are present in the private subnet, you will need to have the private IPs. So if I go here, the backend instances do not have a public IP. So if I go to the backend instance, see there's no public IP here, only private IP address is available. So to connect to the private instances, you will need the private IP address. So I've already noted mine down. So this is here. So I'll connect to the instance which is present in the private subnet. Okay, so now I'll show you the demo how you can actually connect to the MySQL instance. So if you see here, there is a backend endpoint, and I've also mentioned the DB name, DB root, and sorry, DB user and DB password. So you can use this kind of command to connect to the MySQL instance. So I'll show you. Just remove the port number here. Okay, so it will prompt for the password, and I'll enter the password. Okay, so now we are connected to the MySQL database as well. So this was the demo. Now you can access this, and yeah, gone through the application and how we are setting up the infrastructure and architecture. I'll briefly give you the overview of the code. So I'll start with the Jenkins pipeline that I have created. So all of this is available in my GitHub repository. So you can replicate this and try out different applications of your own. So I'll talk about the Jenkins pipeline. So I've created a pipeline project, and I insist that you should set up Jenkins in your local machine and not on a cloud instance, because I tried it with the T2 micro instance setting up the Jenkins. It was not able to handle the creation of 3-tier infrastructure. So instead, I set up the Jenkins using Docker on my local machine. So talking about the pipeline, so these all parameters are, when you click on the initialize infrastructure button, all these parameters are accessed here. These come from the MongoDB database. I'll show you the API later, and you'll set the environment here, basically the access key, secret access key, and all. And the first stage is checkout. So it will check out the repository to get the Terraform modules and code. Then it will check the AWS credentials, as I mentioned, to check whether the credentials that you have entered are actually AWS credentials or not. Then it will create a S3 bucket. As I mentioned, this S3 bucket is for configuring the remote backend. So if it is not present, it will create one. Otherwise, it will not create one. Then we'll start with Terraform init. If you notice, I have written with environment here. So what this will do is that the AWS credentials will be sent here along to run this command. So Terraform init will be run here. Then Terraform plan. Then Terraform action, where all the instances will be created. I'll show you the console log in just a minute. And after that, capture Terraform output will be run. I showed you the JSON file from my email, and this was the code to send the email. I use the email extension plugin, and when the event is a success, then and if the action is applied, like the infrastructure is being created, then the payload will be set here: email action active, Terraform output, the Terraform JSON file, and an API will be called here. As you can see, I've used an ngrok here. So this is for creating the endpoint to provide to Jenkins. Since it is running in the Docker instance, so it will need access to the API which is running on my local machine. Yeah, that's it for the pipeline. I'll show you a brief. I'll show you the output. Okay, so some part is cut here, but this is the Terraform plan which is happening here. This all is Terraform plan. Okay. Almost around 60 resources are created here. Let's scroll down to the bottom. See, you will see the endpoint, backend endpoint, load balancer endpoints, Terraform JSON file, the email SMTP. Okay. Video is getting very long. I'll just give a brief overview of the file structure and what are the main files you should know when you are trying to replicate this project. So first I'll talk about the client files. So this in the client folder, all the front end code is present. I have divided it into create form page, dashboard page. So it is very simple. You can check out it here. Then we have the server where all the APIs are present. You also need an environment file, and the contents of the environment file should be this one: Jenkins username, Jenkins token, API token. This all should be present in the environment file. And I'll show you the APIs. So as you can see, the verify signature and the API Clerk webhook. So I provided the ngrok endpoint to Clerk so that whenever a new user is created, its details are saved in the MongoDB database. So this is for that. Then fetching the credentials. Uh, then this is for saving the credentials, and this is the API which calls the Jenkins job. So as you can see, I have this is the Jenkins job API token. Action is apply here. Access key I'm sending it here. Secret key I'm sending it here. And this is a destroy API. And this is a check active configuration API. And this API is called from the Jenkins instance to update the credentials in the MongoDB database. And I'll now show you the Terraform code. So firstly, the backend remote backend is set up using this file backend.tf. This will be automatically created by the Jenkins pipeline, so no need to worry here. And next file is the output file for the project. So as you can see, these are the outputs will be present in the front end interface as well. Then this is a Terraform TF wires file. So from here you can define which IPs will be allowed to connect to the bastion host, and you can set which database username you want, password you want, etc. Also the AMI you can select according to your AWS account and preferences. Okay, so now I'll talk about the different modules that I've created. So I've divided into four parts: database, EC2, load balancer, and VPC. So these are quite elaborate files. So you can access the GitHub repository and have a look. Since this video is getting very long, I'll not explain it here, but if I get a good response of the project, I'll surely do it. And I'll explain the main.tf file where I've connected all the modules. So I provided all the variables here to the different modules. So you can tweak this according to your preferences. And one more thing, frontend.sh file. So the frontend instances are created using a launch template, and this is the script which will run on each and every EC2 instance for the frontend when they are set up. So similarly for the backend.sh, so you can modify this, and you can also clone your repositories here and start your React projects, etc. So this was it. I hope you enjoyed the project, and let me know in the comments if you want anything new, any explanations or any difficulties or any issues that you face, so that we can together solve this and make this project a lot better. So it is kind of like an open source project right now. So if you want to contribute to this, you can reach out to me. Okay. Thank you guys.